3 together. So as you can see here, the picture, the graph that you see is the first derivative of f. And then notice that f prime has horizontal tangent line, so right over here, when x equals -3 and x equals +2, x equals 5, not bad, but vertical tangent when x equals 3. Oh, okay. What does it mean by vertical tangent? That means when f prime is not defined. All right, so given that, let's try to look at the questions here. Find all values of x where f attains relatively minimum. Relatively minimum, that means f prime, which is this function that you see, has to go from negative to positive. So that's, oh, right over here, only one place. So A, x has to be equal to -1 because when f prime goes from negative to positive, f has relatively minimum. All right, that's it. You can just, write that up in words, right? That'd be better. Now let's look at part B. Part B is find the relative maximum. Then that's obviously going from positive to negative, and we see only one point here. X equals -5 when f prime goes from positive to negative, f has relatively maximum. All right, not bad at all. All right, let's try to look at part C. Find all values of x where second derivative is negative. The fact the second derivative is negative, then the first derivative has to be decreasing. Where do you see that? First derivative is decreasing from here to here. Okay. -7 to -3. That's one interval. How about the second one? 2 to 5. Yes, but don't forget, you see, they said if there's a vertical tangent when x equals 3, that means when x equals 3, there's no first derivative. First derivative is undefined. So therefore, you have to realize that then when the first derivative doesn't exist, then second derivative cannot exist either. So therefore, we gotta say 2 to 3 or 3 to 5 as well. Because, or when, first derivative is decreasing, f double prime is negative. So that's what we realize. Part D, let's look at it. At what value of x does f attain its absolute maximum? Absolute maximum, that means we have to consider all the critical points and then the endpoint. So that means I have to check upon here, 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 and here. Technically here as well, because that's when the first derivative is non-existent. All right, but the thing is, I don't know the actual function, so therefore I only know them graphically. So the maximum value, that means area under this curve starting from -7 has to be the biggest. So I see a little bit of positive here, but this is negative. So they kind of undo each other a little bit. But I see a lot of positive area here. That means when I integrate this one, f of x at this particular point is far greater than f of x here, or here, or here, because area under the curve is much greater. And how about here? More positive area. So therefore, we get to realize that when x equals 7, that's when you're going to have absolute maximum, because area under f prime of y equals f prime of x is greatest from -7 when x is equal to what? 7. That would be the reasoning why you will have absolute maximum when x equals 7 here. Alrighty, and I'll see you later.